Hello, and welcome to the Call Admission Control webinar hosted by Stephen McCassey. I'm Chris Moggitt from TrainSignal, and I'd like to take a minute to tell you what to expect in the next hour. First, I'd like to draw your attention to the questions box in your webinar control panel. Stephen will be answering questions today, so please feel free to submit your questions during the presentation. I also encourage you to use hashtag TrainSignalLive if you're using Twitter to tweet us your questions and comments, and you'll have a chance to win prizes, including a t-shirt. Today's presentation is also going to be recorded and available to view on our blog. We'll email you the link in a few days. After you exit the webinar, you'll be prompted to take a short survey. We'd love to hear from you, so please take a few minutes to complete it. And with that, thanks for joining us today. Here's Stephen.
Thanks for the introduction, Chris. And I want to welcome everybody to the webinar on call admission control. And to start this off, I want to give you all an introduction of what this is going to be about. Microsoft Lync Server 2013 is following in the footsteps of the prior version of the product, Lync Server 2010, in the sense that when Microsoft released the product, they introduced a product with a lot of new features. And one of these new features is call admission control. So we had it with Lync Server 2010. We still have it with Lync Server 2013. In this segment, we're going to talk about call admission control. And the basic premise behind call admission control is that it provides bandwidth management for your real-time communication with your Lync server-based environment. So whether you've got real-time audio, real-time video, when you're participating in a conference using real-time communication, this is the component that allows us to put restraints or restrictions on how much bandwidth that you can possibly soak up, whether it's on a total aggregate basis or on a per session basis. So to look at some of the features that we have, it's very simple to deploy. Lync Server 2013 has the built-in support for call admission control. So what I mean by this is that you don't have to go out, you don't have to purchase any additional hardware. We know how we always want to save money. Well, there's nothing additional. It's built right into the product. You just have to define it throughout your topology, and you have to configure it inside of the product. Other features that we have, the address, it has the ability to address roaming users in what's called multiple points of presence. So if a user is trying to place a call, let's say, for example, that you're placing a real-time audio call. The call admission control functionality is based upon the endpoints of your client. It's based upon your IP addressing. So, for example, if I try to place a call to Bob over an HR across the WAN link, so we'll assume we're making a real-time audio call, the call admission control is going to base the bandwidth restrictions based off of where the source is, the source IP address, and also where that destination IP address is. And it has the ability to apply the network bandwidth policy profiles that we as administrators define for Microsoft Lync Server. So it can be applied to your real-time traffic, real-time audio, real-time video. So again, audio-video conferencing sessions. But you do want to know that it does not apply to your data. So for example, Microsoft Lync Server is obviously a very robust product where it supports audio, video. You've got your collaboration with application sharing and desktop sharing and stuff like that, whiteboard polling and all that. It does not handle the control over the data collaboration. It's just the audio and the video. So one of the things that we're going to see as we go through this demonstration is we're going to provide an overview of what this is. We're going to provide an overview of how it gets laid out within your network. And I'll try to keep it short and sweet because we're limiting this to an hour. So I'll try to keep it nice and short so you guys get a lot of punch to the presentation without putting you to sleep. We're going to look at providing the application flexibility through application of this technology to different types of topologies. So we're going to talk about how you can apply it in different types of scenarios. One of the features that we're going to be looking at is how this gets applied within your environment. And again, before we go into all the slides and all the details of it, to give you an overview of the basic premise behind it. When you deploy your Microsoft Lync environment and you go out and you define what's called your topology, as you define your topology, you can specify if you want to install the network bandwidth policy services. Well, the way that you typically set this up is you define it inside of your topology builder, and it gets applied to the first pool configured within your central site. So if you have multiple, if, for example, if you go out and you set up multiple geographic locations and multiple, so let's say I have a central site over here in the US and maybe I've got another central site that I set up over in Europe or something, you would have the bandwidth policy services running in the first pool configured of each of your central sites. So you end up with a single central site per network region, which you work that into your design when you're originally setting this up. So you're basically going to have one bandwidth policy service per network region running within a pool. And it manages the policies for that particular region. And what happens is the servers within the pool, they sync up within every 15 seconds. So you kind of have a bunch of servers working together if you have a pool of servers. And very similar to the prior version of Lync server where, if you have the standard edition, you have one server per pool. But with the enterprise edition, you have the ability to install multiple servers per pool, and you get that higher level of availability. Well, this product here is not any different, where you can set up multiple servers per pool, and you get that call admission control network policy services being forced by that first pool that you set up per site, which again is typically associated with a region. Well, in this slide over here, we see an example of a slide. In fact, you guys are going to see several slides that come from TechNet. You can gain access to a lot of this stuff at TechNet Online. Microsoft has released a lot of the information that goes along with Microsoft Lync server, so this is readily available. But here you're seeing in the diagram an example of a client that's communicating over with a Microsoft Lync mediation server. And the mediation server here is communicating over to the right with some form of connectivity, whether it's a gateway, an IP-based PBX, or possibly a SIP trunk connection, maybe through a session border controller out to an ITSP, an Internet Telephony Services provider. Well, the nature of this slide is to exemplify that when a Lync client communicates through the mediation server and then out through some form of a gateway, call admission control can be enforced on both sides of the connection, from the client to the mediation server and the mediation server over to the gateway. Now, an important point that we're going to see as I go through my demonstration and we go through the architecture of how this is laid out is that call admission control gets enforced on links from sites connecting into a region or from region connectivity over to another region within your environment. If you have clients that are using a feature called media bypass is a feature where when a client places a call that's going out to your PSTN connection of whatever type, the SIP traffic session initiation protocol for your dialed call has to go through the mediation server. Now, this is no different with Lync Server 2013 than it was with 2010. Very similar, where your SIP traffic has to go through the mediation server, but if you're using media bypass, the audio portion of your call can bypass that mediation server. So again, if you go back to the older versions of OCS, your audio had to go through the mediation server, and that puts a lot of extra overhead on your server. And it also means you get more latency, possibly more drop packets. So Microsoft changed the architecture for that. If your client is communicating directly with the gateway, the requirement of that is your gateway has to be local to your client. In that case there, the call admission control would not be enforced on that data stream. Another important point to note about this is that if you're using call admission control, this is a feature that I mentioned came out with Lync Server 2010. So it's a feature that is only supported by the newer clients. And it gets enforced by the client that is being called. So as an example of this, if I have a user that's in downtown New York, and they're placing a call to a user in our Chicago office, the user that's being called over in Chicago, that is the client that's going to enforce the policy settings. And in essence, what happens is, when I place a call to the user in Chicago, the client-side software on the user in Chicago will communicate with the network policy services to see if it's okay to accept the call. Now, the part that we have not seen yet is that we as administrators of Microsoft Lync Server, we can define the amount of bandwidth that we want to allocate for real-time audio and or real-time video, both on an aggregate total basis and on a per session basis. So the obvious value is that if I put a limit on how much audio you can use across the link, I can prevent the Microsoft Lync environment and real-time audio or video from using up too much bandwidth. So if you're competing for bandwidth with other applications or whatever, we can restrict the product. We can also put restrictions down to the per session basis. So if I have a user that's placing an audio call across the link, I can restrict how much bandwidth you can use, which behind the scenes will restrict the codecs that you can use. and some of the more advanced features with the codecs, like maybe, for example, not being able to use forward error correction. Another example that I think most people, even if you're kind of new to Lync, would understand is that we've got different codecs that can be used for video streams. And if I put a restriction on how much bandwidth you can use for video, well, I might restrict you to using SIP or VGA support, which uses a lot less bandwidth than using high definition. Well, here in this slide, we see an example of a legacy client, and this is a real legacy client, Office Communication Server 2007 R2 and earlier. Microsoft did not come out with the call admission control until the Lync 2010 product. So if you were to place a call to a client that was running the Office Communicator client-side software, your bandwidth would not be managed because this client doesn't know what a bandwidth policy is. It doesn't know how to go out and to enforce that policy. But on the flip side, if I apply call admission control and bandwidth management on my network, calls that are going into a Lync Server 2010 based client, whether it's the Lync client, it could be the attendant client, it could be an IP-based phone running Lync Phone Edition. These are all examples of clients that will enforce the policy. So what you expect to see as an end user is your phone doesn't even ring until your client-side software is checked to see if it's okay to accept the call. Now, the other piece which I haven't mentioned, which is also very, very important, is that one of the added values that you have with the call admission control is that if you have a client that's trying to place a call across the WAN link, and if the WAN link has too much bandwidth being used up, call admission control can route the call across another media. So the default of the product or the preferred route would be that if I can't route the call across our WAN link, the internal connection that we have inside of our company, well, the next choice would be, well, let's route it out across our edge servers if we have edge servers at the different locations. And another choice would be, well, if that client that I'm trying to call is enterprise voice enabled, we can also route the calls out through the PSTN connection. So instead of it being a real-time audio call across the WAN link, it ends up being an enterprise voice call going out through our PSTN lines. Again, here's another slide that you can find out at TechNet, and this is an example of the high-level architecture of how you go about setting this up. And to give you an idea of what we're looking at, it's the high-level architecture of a network environment where I've got several different regions. Well, when you first set up call admission control, if you want to control bandwidth usage, you've got to get acclimated to some of the different terms and some of the different Microsoft Lync Server network configuration settings that you're going to have to define. Well, first of all, let's start off over here to the left where I have a region called North America. Inside of Microsoft Lync Server, if you want to restrict bandwidth utilization, a region is a network hub for connectivity. So in this example here, I've got a region called North America, and when you define a region, you have to associate that region with a Microsoft Lync Central site. So what you typically have is regions associated with central sites and one central site only. So in this case here, if I were to have three regions, I've got a North America region, a Europe, Middle East, Africa, and an Asia Pacific region. That tells me that I would have to have these regions associated with three central sites. For the sake of my demonstration, I've actually created a couple of additional regions, and we're going to create one together, so we'll get to see how it would be to set up something very similar to what you're seeing here on the screen. So number one, you've got to define your regions, and a region is kind of like a major hub for networking. Your regions are typically interconnected by major pipelines. So you'll notice over here, I've got this major connection that connects North America over to EMA, or Europe, Middle East, Africa. Well, this little double-ended arrow that you're seeing is a representation of a network link. And as you'll notice on the link, I've got an audio limit of 20,000 kbps, an audio session limit of 175, a video limit of 14,000, and a video session limit of 700. So the audio limit and the video limit, those are total aggregate limits. You're telling the Microsoft Lync product that this is all I'm going to allow you to use. So if we max that out and a client tries to establish a real-time audio or video call, the Microsoft Lync server can prevent that. Or it can have that call get rerouted across another media. Your audio calls can get rerouted across the Lync edge out through the internet, or they can get rerouted out through PSTN connections. Your video cannot get routed across your PSTN connections. That would be across the internet exclusively. Well, the other things that you're seeing in the diagram is that when you define your regions, regions are actually defined by the network sites, Microsoft Lync network sites. So over to the left, I've got North America, and I have Chicago, Detroit, and New York. I also have my Portland, Reno, and Albuquerque sites. Well, in this case here, you can see that Chicago, Detroit, and New York, they put those inside of the ellipse for North America. Well, I'll be honest with you guys, the configuration for this is almost identical. The only difference that you're going to see is that when I create these different sites, like Portland, Reno, and Albuquerque, if they are not well connected within the region, and I want to apply a network bandwidth policy profile to the link, well, when I create that site and I attach it to the region, we're going to associate it with this policy profile that we create. So as you can imagine, in order to apply call admission control, you have to have a really good understanding of your network topology, where you have physical locations, where your company has a presence. You have to understand your IP routing, and in this case, over here, when we define our sites, you also have to identify your subnetting, because your IP site, these sites that you're seeing, what we call link network sites, these are defined by IP subnets. So in this case over here, my region is defined by the sites that are associated with it, and my sites are going to be defined by IP subnets. So in this case, I could create a region called North America and associate it with a Link Central site over in North America, most likely. I could create a region called EMMA and associate that with a Link Central site over there in Europe, Middle East, Africa. And I could also do the same thing with Asia Pacific. And then I go in and I define the sites and I link them to the region. And when you link those sites to the region, you'll be able to define if you want to apply a policy profile to those links. So what you guys are going to see, you people are going to see in just a moment, is we're going to go in and we're going to see how to walk through the steps of setting this all up. But one of the things we're going to talk about is your bandwidth utilization. So here you see I've got like an audio limit of 4,000 kbps and a per session limit of 175, and then I've got my video limit, my max aggregate, and then I've also got my per session. We're going to talk about these a little bit just so you get an idea of like what your clients are going to be using for codecs. So with that said, here we have an example of your bandwidth used by codecs. I've got real-time audio, narrowband and wideband, and you can see that the product uses a different amount of bandwidth depending upon whether we're using forward error correction or not. Now, forward error correction, it's kind of like RAID for network transmission. When I send real-time audio communication over to another client, the communication stack that Microsoft likes to use, the real-time audio support, it has the ability to dynamically adjust based upon your networking conditions. So if, let's say, for example, that Bob is communicating across the wide area network with Mary over in HR in downtown New York. Well, as the call goes across the wavelength, if the communication starts to break up, we start dropping packets, we start getting higher latency, your client can automatically switch over to using forward error correction, but it's bandwidth, because you're putting redundancy into the data packets. Well, the reason why I've actually added this here into this quick PowerPoint presentation is I wanted to give you guys an example of what type of bandwidth is typically used per audio or video stream by your clients. So whether you're using real-time audio narrowband or wideband with or without forward error correction, you can see that we're coming in under 100 kbps per audio stream. Now, Microsoft Lync Server, when you're participating in a conference, you've got support for G722 for conferencing. You've also got support for Siren. Siren uses a lot less bandwidth, and it's provided for backwards compatibility. We've got G711 for intercommunication, typically over with your third-party devices like a gateway or something like that. And then down below here, you can see that I've got real-time video using SIF. That comes in at the lowest amount. It usually uses about 200 kbps, but we estimate it up around 250 to 300. You've got your real-time video, which uses about 500 usually, but here you see that that's been raised up to about 610 for planning purposes. So if you look at the different types of calls or the different types of communication, on this slide right here, we see an example of how you can actually apply your policies, and you can restrict what your clients will have available to them. So I'll give you an example. As I look at the scenarios in this diagram, I see that I have peer-to-peer audio calls, and as I navigate across here, you have bandwidth required optimized for quantity. if I wanted to allow the clients to have more peer-to-peer audio calls across a link that doesn't have as much bandwidth, I got a lot of users, but I don't have an unlimited amount of bandwidth. Well, I can restrict this to 45 kbps per audio stream. And what that does is it restricts you to using a lower codec. And again, you can do the same thing whether you're dealing with your conferencing integration, so your clients with their audio into a conference call. We can do the same thing when we're looking at connecting over from clients to mediation servers. So as I navigate across here, you can see that I can use different amounts of bandwidth. So this is where that per session limit comes into play. So if I have a remote office that's across a WAN link, and I've got a lot of bandwidth, I've got a high-speed data links, and I'm not worried about bandwidth, well, I'm all about quality. And if I don't have the bandwidth, and I have people complaining that they can't get their sessions going, here's where we might make that choice, and we might either bite the bullet and get some higher speed links with more bandwidth, or we might restrict what the clients have the ability to use for different codecs. Now, when you go to set this up, when you go to apply it in your environment, we're going to see in my demonstration how to create a region and how to associate sites within the region. So for any of you guys out there that are looking at deploying Microsoft Lync Server 2013, where maybe you got a company and you only have one central site and you have one region. And what you typically do in a case like this is you define your physical locations as different sites, and they interconnect into the region. And then you can define on the different links the sites connecting into the region if you want to apply network bandwidth policy profiles to those links. You want to put a limit on how much bandwidth can be used by those clients. So in this example over here, let's say, for example, that you have call admission control on a multi-protocol label switch-based network. Well, what you can do there is you can define the MPLS network environment as your region, and then you can define your sites and then interconnect them into the region. Now, again, don't worry about the mechanics of it because we're going to see a demonstration in just a moment. I want to make sure you guys get the full gist of how you set it up. The next slide, you have call admission control. If you're setting up call admission control over a session initiation protocol trunk connection, well, so let's say, for example, that I'm using a SIP trunk connection out to my ITSP. Well, in order to support something like this, what we can do is we can use what's called an inter-site policy. An inter-site policy allows you to define a policy between your sites. So I'm going to go back a couple of slides, and if you guys can bear with me for a second. If I take a look at this diagram over here, I've got Reno and I have Albuquerque. Well, if a client over here in Reno placed a call over to Chicago, we've got a bandwidth policy profile here that would get enforced by your network policy services. And if the client called from Reno over to Europe, Middle East, Africa, well, now the call goes from Reno, it's connecting into the region, so I have a limit here, and I also have a limit over here on that inter-region link. So as we go through the process of setting this up, you can apply limits on the connectivity from the site to the region, and also on the link that connects one region to another. So one of the things that we haven't seen yet, and we're going to see this in just a minute, is that you have to tell the product how the traffic routes from one region to another region by defining something called an inter-region route. So we're going to see how to create regions, how to create sites and subnets. We're going to see how to define these network policies, these network bandwidth policy profiles. We'll also see how to create the inter-region links and also how to define the inter-region routes. And the routes tell the product that if traffic has to go from this region to that region, the traffic has to go across this link. So if I had traffic going from North America to EMEA, it would have to go across this link. But if it had to go across from North America to over to Asia Pacific, it would have to go across multiple links. Question over here came in and says, can you link a site to more than one link at a time? Actually, your question, I don't understand your question 100%, Steve, but let me take a poke at it. When you create a site can only be associated with one region. And when you link your site to the region, you can specify the network bandwidth policy profile, the limit that you want to apply on that connection. And I think if you're new to it, you're going to see it in a minute. I think you're going to say, okay, I understand that now. It's going to be very clear to you. And with that said over here, I've got another example. So going back over here, if you want to set up a connection that's going, or if you want to apply a bandwidth policy limit on a connection going from a network site over to your ITSP cloud at your provider, what you would have to do is you would have to define your provider as being a site, and you could define an inter-site policy. An inter-site policy is a policy that says if traffic has to go directly from this site over to that site, well, we're going to use a different limitation. So here's where you might have a bunch of sites that are interconnected to a region, but you might have two sites that have a direct connection to each other. And for those particular sites, you want to put a different limit on them. So if traffic goes from Reno over to Albuquerque, for example, we can say, hey, well, I want to use this particular bandwidth limitation instead. If you have call admission control and it's being applied within your environment, when you're intercommunicating with a third-party PSTN gateway or a PBX, the product can apply limits from the client to the mediation server and from the mediation server over to your defined gateway. You're in this case here, a PSTN gateway. So if I had a client, let's say I had network site 3 and a client was connecting to the mediation server, and then from the mediation server over to the PSTN gateway, well, call admission control could enforce the bandwidth utilization on both legs of the communication, on both sides of the mediation server, if that makes more sense. Okay. Now, here's where we're going to go in. We're going to take a look at a demonstration on how you set this up. And again, for those of you guys out there that are kind of new to this, I think you're gonna see it and say, okay, it doesn't look as bad as it sounds. So what I've done over here is I've just connected over to my my Windows Server-based environment, and I've got a Microsoft Lync Server 2013 box, which I'm going to connect to the control panel. And you people will notice over here I have Activate Windows. This is my lab-based environment that I'm actually presenting this off of. So this Microsoft Lync server that I'm connecting to right now is freshly installed. It's been up and running for about a day. Running great. And for those of you who are new to this, this is what your Lync Server 2013 environment looks like, your control panel. This is your graphical user-based administration control panel. And inside of the control panel, what I want to do here to set up my call admission control is I'm going to navigate down here to my network configuration. And from inside of my network configuration, you'll see up here where I have the global settings. And if I go to the properties for global, you can enable the call admission control within your environment. So that would be one of the first things, is that this is a global setting. Okay? As I navigate across a little bit further, and I click on bandwidth, my bandwidth policies, the full name for this is a network bandwidth policy profile. Well, on the bandwidth policy tab, this is where you can go in and you can define different types of policies that can be applied for sites connecting to regions and regions connecting to each other, what we refer to as regional links. Now, I've created a couple here because I'm going to use them as I go through the demonstration. But as an example of this, if I click on New, and I want to create a new bandwidth policy profile, which you people are going to see me using in just a moment. I'm going to call this one here 20 megabit per second link. And then down here, I define what I want to provide for a total aggregate limit for audio. What's the maximum amount I want to apply for audio across that link? So here, let's say I use like 7,000 kbps, and I'm going to apply an audio session limit of 70 kbps. I will apply a total maximum video limit. So let's put 5,000. And then down below here, there's my video limit is 5,000. And then my video session limit, I'll set that to 170. Now, again, going back to the prior slides, remember we had different numbers based on the codecs you were going to use. So depending upon what I put in here for values for the per session, it will dictate what the clients can use for codecs. So instead of using like 170, I could restrict your per session. Actually, what did I put there? Set 170. I want to jack that up. Not 170. That would have to be much higher than that. So here, if I put like 700 for the video session limit, that would allow me to use CIF and VGA support. If you wanted to support high definition, a high definition typically comes in about 1.2 to 1.5 megabit. So it would require a higher value. So I'm going to restrict my clients so across the WinLinks they're not going to be using high def. and I'll commit that. Now, this bandwidth policy profile right now, it has not been applied to anything. It's just one of multiple now, and I'll be able to use those in my demonstrations. So as you guys can see here that I've gone in before the demonstration, I've created a couple so that, you know, as I go through the demonstration, I don't have to create 3 or 4 of them and waste a lot of time. So here, I've got a 50 megabit per second link, and you can see what I applied for: an audio limit, a per session limit, a video limit, and then also the video per session limit. We'll commit that. So there's my bandwidth policies, which I can apply to my links. Well, let's go over here and take a look at setting up a region. When you define your region, so here I created a couple of regions just like we're in the slide deck. Now, I do want to point out that I only have one central site. So realistically, if you have one central site, you would have one region. I just added a couple in there so it could simulate like I had a couple of other central sites out there, so you can see how you link them together, kind of like what I'm doing in the PowerPoint slide. But here, if I wanted to create a region, you would click on New. You define the name of your region. So here, I'm going to create a region for North America. And then you would link the region with the central site. So in this case over here, you know, I would have the central site in North America. So here, I would just click on it, choose it from the list. And then down below, you've got the option to specify if you want to enable audio or video to be able to take an alternate path, which means that it could actually go out through the internet throughout your edge. So that's what that's saying to me. Can your audio or video go out through the edge environment out onto the internet instead of going across your WAN link? You'll notice at the bottom of the screen my associated sites. Okay? Currently, right now, my region doesn't have any sites associated with it. So let's commit this, and we'll move over to creating a couple of sites. In this case over here, as I open up my sites, actually a good question coming in over here from Avi, which ports do I need to open up on my routers? I'm gonna give you a very blanket statement on this. Microsoft Lync server uses a tremendous number of ports. What I want to reference you to is, and I'm actually going to type this in the chat window. There is a, in fact, I'll pull it up on the screen. It's a very good question over here. And here, inside of Google, I have a file here, Lync. Lync 2010 Protocol Workloads poster. The Microsoft Lync Protocol Workloads poster will give you a pretty good understanding of the type of communication traffic that your Microsoft Lync server environment is going to be using. Now, again, there's going to be 2 pieces to my answer here. If I open up the Protocol Workloads poster, I'm going to download it. I'm going to try to download it. And when you open up the Protocol poster, it gives you a really good understanding of the type of traffic that your Microsoft Lync environment is going to have. So as you can see there, it's a very busy diagram. And as you're going to see in the diagram, there's a lot of activity, a lot of traffic going on. So as an example here, you've got your edge environment, you've got your edge pool, your reverse proxy. Now, this is actually, this documentation it goes along with Lync Server 2010, but it's not identical with Lync Server 2013, but it's very similar. When you're setting up a Microsoft Lync environment, what you typically want to do when you're coming up with your original design is you want to get a hold of a tool which is called the Lync Server 2013 Planning Tool. The Lync Server 2013 Planning Tool allows you to basically walk through the process of defining you know, how you want your environment set up, what features you're going to use, what type of communication, if you have backwards compatibility with clients and stuff like that, and it will typically give you your firewall information. So if you're brainstorming on, hey, what ports do I have to open up, you want to download the Lync Server 2013 Planning Tool, and I believe it just became available for download to the general public about 2 weeks ago, maybe 3 weeks ago at most. It just came out. But again, my answer to this is there's a lot of ports. There's a tremendous amount of them. And so going back over here, I've got my regions. Here, I created a region called North America. And when I created the region, I specified that it's associated with a central site called New York. So in this case here, if I really had a couple of other regions like Europe, Middle East, Africa, and I had an Asia Pacific, they would be associated with central sites also. And again, just for the sake of the demo, I wanted to show you guys how you can define the routes between the different regions. So we're going to talk about regional links and regional routes, so I just added them in so I'll be able to exemplify that for you. If I take a look over here at my sites, this is where you define your Microsoft Lync network sites as opposed to your central site or your branch sites. A Lync network site is very similar to a site that you would define inside of Active Directory sites and services. You click on New, you give your site a name. So here I have a New York site. You specify the region that the site is associated with. So here, North America. So the New York site is associated with the region called North America. And then down below here, this is where you define if you want to apply a network bandwidth policy profile. Here you see it's called bandwidth policy. Now you can see that link that I just set up, or that policy that I just set up a moment ago, and here's where I can apply it. Now, when you're setting up your sites are defined by IP subnets, so we're going to have to define those in just a moment. Let's create a couple of other sites. I'm going to create another site over here, and this site over here, we're going to call this one Chicago. My Chicago site is associated with the region called North America. And here you can define a bandwidth policy for that one also. So maybe I've got like a connection to the MPLS network where I'm going to use a 10 megabit per second link. And again, here I've only got a couple of sites for this demonstration, but you'd have to set it up for all your sites that you got. You got to make sure that you're accounting for all your subnets because this is based upon IP addressing. If I had other sites here, so for example, maybe I've got my Asia Pacific, so maybe I have a Manila site. You'd specify the region that it was associated with, like Asia Pacific, and then you could define if there's a bandwidth policy over there for the connection from the site into the region. Or maybe there isn't one. Maybe there's none. Maybe there's no limit over there. We'll commit that. So what is a site defined by? Well, we saw a region is defined by the sites, but sites are defined by subnets. So if I click on the subnets, this is where you go in and you start creating your IP subnets. I'll click on New. You specify your subnet ID. So here I'll put in 10.0.10.0. You define the number of bits that you want to use inside of your subnet mask. And if any of you guys are like me, I remember the first time I went in here, I typed in 255.255.255.0. And when I tabbed down, it said, hey, you can't do that. It wanted an integer format. And obviously, there's something wrong with my keyboard. Try that again. So here, what you're looking for is CIDR notation. Let's put in 24 bits in the subnet mask. Here, I'm going to specify the network site that my subnet is associated with. New York. Click on Commit. Let's create another subnet. Let's say that I have a 10.0.20.0 subnet, and I'm going to say that that has 24 bits in the subnet mask, and that is going to be associated over with my Chicago office. So again, here's where I would have to get all my subnets, and I would apply them to sites. And realistically, if I had a lot of them, I would be scripting this using a CSV file as input fodder for a commandlet. But if I click on New, let's create one more subnet over here. Let's use a 10.0.30.0 subnet with 24 bits in the subnet mask, and we're going to link that over there with our site that we have called Manila. And again, you've got descriptions, and those are optional. So now what you guys are seeing is that I have sites defined by IP subnets, and those sites are associated with regions, and some of those sites actually have limits on the amount of bandwidth that can be used for connectivity into the region. And that will get enforced by your bandwidth policy services. If I look over here at this tab labeled regional link, this is where you can define a connection that connects one region to another. To me, a regional link is a representation of a network pipeline that connects region 1 over to region 2. So here's where your company might have a T1 line or a T3 line or something like that. So here I'll call this one North America. We'll just call this one NA2. And here I'll say this one is APAC. So this is my North America to Asia Pacific connection. And here I'll specify region 1 is North America. Region number 2 is Asia Pacific. And got to be honest with you guys, what you're really doing is you're defining a network connection, and you can define if there's a bandwidth policy on that connection. So I'm going to put a limit on that. So I have North America to Asia Pacific, and maybe I have another connection, and this other connection over here, this other pipeline I have, is going to connect Asia Pacific over to Europe, Middle East, Africa. So here we'll put APAC to EMA. And once again, if you have a limit on your bandwidth, you can provide that here. You can define what bandwidth policy you want to attach to that connection. And I'll commit that. Now, here's the final piece. I just told the product that I have these links that have limits on them, but you have to tell the product that if traffic has to go from this region over to that region, these are the links that the traffic has to go across. So in this case over here, you see I have North America to Asia Pacific. Well, let's create a regional route that says if traffic goes from North America over to Asia Pacific, the traffic is going to go across the link called North America to Asia Pacific. So now the network policy services will know how to calculate bandwidth. Oops, try that again. NA to APAC, that's my North America to Asia Pacific route. And it will go across this one link. Let's create another one. Now, in this other link, on this other link, we're going to create a link that goes from EMA over to Asia Pacific. And you can see there, I have my EMA to Asia Pacific route. We'll click on OK, and we'll give it a name. And there I accept that. So you can see that I'm telling the product that if traffic has to go from region 1 to region 2, these are the links that the traffic has to go across. And here's the grand finale. What if I have to go from North America over to Asia Pacific? So here, if traffic is going to go from North America over to Asia Pacific, now the traffic is going to have to go across 2 of those links here, and I can define them both. Sorry, guys. Sounds like I'm a smoker over here. I think I inhaled something as I was lecturing. Let's go over here to NA APAC link. And I can commit that. Whoops, that's the one I already did. All right, so as you're seeing here, I got EMA to APAC, APAC. So this should be North America to EMA. Try that one more time. North America is connecting over to EMA, and it's going to go across 2 links to get there. And this is where you put more than 45 minutes into your design. So here we're going to call this one NA EMA link. So now if you have real-time audio or video that had to go from a site over in North America over to a site over in Europe, Middle East, Africa, the product knows that it has to go across this link that has a limit of 50 meg, that bandwidth policy that's 50 megabit, and it also has the bandwidth policy on the other link that I think was set to 20 megabit. And it can tally that. So if you could think of the network bandwidth policy services running on your central site within a pool, it reminds me of a big calculator. It's like a Microsoft Excel spreadsheet. If you can imagine, it's tracking your links. And as a client gets a connection going, it pre-allocates a certain amount of bandwidth. Even though the client may not be using it, it says, okay, we're going to pre-allocate that much bandwidth. And I always say it reminds me of a highway. For any of you guys, any of you people who do the commute, you get out after work, or you go in early in the morning, and when there's too much traffic on the highway, we know what happens. Well, it's similar when you're dealing with your network traffic with real-time audio or real-time video. You get too much traffic on the network, and your clients are going to get bottlenecked. So with that said over here, I want to show you guys just one more quick thing before I close out of here and end off the demonstration. If I go up here to my voice routing, and inside of the voice policies, your voice policies are something that we use to enforce some settings for your enterprise voice-enabled users. And these can be applied at different levels, like at the user level, the site level. You can apply them globally. But the point I want to make here is that For people inside of your organization that are more important as far as being able to receive calls coming in. So I don't know of too many companies where you don't have people that have high-level positions where, you want to make sure, like if I have a top-level executive, I don't want to prevent their call from coming in. So you can use this feature here, and it's labeled Enable Bandwidth Policy Override. The Enable Bandwidth Policy Override tells the Microsoft Lync client, we're not going to enforce the bandwidth policies on you for your incoming calls. So when a call comes into this client, it's not going to go to the network policy service to see if it's okay to accept the call, because that client has to be able to receive its calls. You've also got the option here labeled Enable PSTN Reroute, and that's what's telling your client that if your call cannot get placed across the WAN link, well, as a call comes in, the network policy services can prevent that call from going across the link. Well, that's what tells your client, well, that call can get rerouted across another media, like, for example, out through the internet. And let's shrink this down over here. And we go back over here to our slide deck. So that right there, guys, that is an overview of the call admission control, which, again, the basic premise behind it is that it is all about bandwidth management. Whether you're integrating Microsoft Lync environment with or without quality of service, the added value now is that you can restrict what Microsoft Lync can use. So you now have the ability to put a rein on the product, so it can't just use whatever it wants. And again, this came out back with the Lync Server 2010 based product. So with that in mind, here I want to wrap it up with some information for the train signal based environment. For anybody who wants to stay in touch with train signal, you've got www.facebook.com/trainsignal. You've got the Twitter. We've got YouTube, www.youtube.com/trainsignal-inc. And they're also available out there at LinkedIn, /company/trainsignal. And just a key point over here, before you guys start throwing the questions, I know a couple of people have asked questions. I am going to be available for you, more than willing to answer your questions. So I'll give you guys a chance to fire away, whether you want to use your microphone or the chat window. I also want to point out that TrainSignal has released a Microsoft Lync Server 2013 video. From my understanding, it just got released today. And in the near future, we're going to be coming out with another video which is geared towards the core. So anybody looking at the Microsoft Lync certification process in the core exam, there is going to be another video series coming out in several months that will be geared towards that as well. So once again, we're going to open it up to questions. And for anybody who's going to be leaving the session, I also want to say thank you guys for joining us. And I really enjoy giving these presentations. So once again, if you guys have any questions, feel free to put on your mic and fire away.
Actually, if you guys have any questions, please submit them through the questions box. I believe your mics are disabled. But again, last chance for Stephen, in case you have any last-minute tips you want to get from him. But if not, we're, again, thankful you joined us today. You can always email us at webinars@trainsignal.com in case there was something you didn't think of. And as a reminder, today's webinar was recorded and will be available to view at trainsignal.com/blog/webinars. We'll also email you the link within a few days. And remember, as you leave, please fill out the survey. We really appreciate it. Thanks again, and have a great day.